Hello, hi everyone, good afternoon and welcome to the new series. So this is for grade 10 students. We have started Pioneer series. This is the first class. So welcome you all. Hi study. Hello Ayush. Hello Easy Fizzy. Alright, so let's begin. We are going to be very slow, we are not going to rush. So we'll spend some time on each and every concept and we'll solve. So let's begin. So our today's lecture is laws of reflection. So we are going to study the laws of reflection today. Hi Ayush, good afternoon. So if you are seeing me for the first time, this is about me. So I have a PhD in physics from National University of Singapore. I have BSMS dual degree from ISA Pune. I was ranker in IIT Advanced and also in KPY. So let's start. So these are the chapters I'll be covering in this Pioneer series, and this will go for, let's say, next 3-4 months. We'll see. Okay. So our topic, reflection of light. So tell me, what is reflection? How many of you know what is the reflection of light? Any idea? Any idea what is reflection of light? You have seen here, there is a mountain, there is a lake, and water is still, it is not moving. So what do you see? You see the reflection of this mountain in the water, or there is a mirror. You see the reflection of your face in the mirror. Hello, Happy Shine. Yes, correct, nice. So what is reflection? Bouncing of the light. So light will fall onto this lake, it will bounce back. Yes, light will fall onto the mirror, it will bounce back. So bouncing of the light from the smooth surface, that is called as reflection of light. Nice, awesome. So now, do you know, like, not all the surface can reflect the light uniformly. For example, there is a wall or there is a floor on the ground. So you cannot see your image in the wall, right? Can you see? No, you can see your image only in the mirror or in a water which is very smooth, not in the river. So why is that? Because you see, if it is a mirror, the surface is very smooth. If it is wall, surface is going to be very rough. You see the surface? So now what happens? Let's suppose if there is an object here, from the object these are the incident rays. They are called as incident rays. These incident rays, they fall onto the smooth surface. Here the incident rays, they fall onto the rough surface. So now what happens? From both the surfaces, light is bouncing back or light is reflecting here. So when the light reflects, because there is a smooth surface, there is a uniform reflection. So even the reflected rays, they are parallel to each other. But if the surface is rough, what do you see here? The reflected rays, they are not parallel. So if the reflected rays, they are not parallel, then you won't see any image. So here, no image. No image. And in this one, image can form. Image can form. So what is the difference? The incident rays, they are parallel to each other. If they fall on the smooth or the regular surface, then reflected rays are parallel. So they can produce the image. If they fall onto the rough surface, the rough is irregular surface. So the reflected ray is not parallel. So no image formation. Hi Anshul, Anshul Patil, MC Stan. Alright, irregular reflection. Yes, Happy Shine. Correct, nice Ayush Chakraborty. Alright. So now solve this question. First question of the day. Hi Music Shorts. How are you, Music Shorts? So does the diffuse reflection means failure of laws of reflection? So we are going to learn laws of reflection. That is our today's topic. So what are the laws of reflection? They define how the reflection should happen. And does the diffuse reflection means the failure of laws of reflection? Answer is no. Answer is no. So diffuse reflection, just a minute, does not mean failure of laws of reflection. Hi sir, Shubhashri from West Bengal. Hi Shubhashri. Hi everyone. Hi Mriganka. Hi Mriganka. Hi everyone. So now there is a difference between regular reflection and diffused reflection. So where do you see regular reflection? On the mirror. So what happens? All the reflected rays, they are parallel to each other. In the diffuse reflections, the reflected rays, they are not parallel. In the regular reflections, it occurs on the smooth or the regular surface, polished surface. Let's suppose there is a marble floor, you put a water on it, then you can see your image. So wherever you can see your face, your image in that object, so that is going to be regular reflection. So image is going to form, right? But if you look at the wall, can you see your image in the wall? No, because that is a diffused reflection. Clear? So these are the differences. Now, when the light, there is a light falling onto the smooth surface, it bounces back. There is a reflection. Can you draw? Why channel name changed? Yeah, there is a management decision, right? So management had decided to change the name. So they have changed. I cannot do anything with that. So now can you draw the path? Can everyone draw the path of the light? So how will you draw? First you need to draw, there is a surface, there is a mirror, smooth surface, right? Mirror. So on the mirror, now there is this one is the incident light or incident ray. There is an incident ray. It will fall onto the mirror and it has bounced back. So this is called as reflected ray. So now what is ray? Ray of light? It is nothing but narrow beam of light which is made up of several rays. So is it like confusing statement? Do you feel that there is a confusing statement? We call this as a incident ray, this one as a reflected ray. But now why it is said that it is made up of several rays, not just a single ray? Because you see, when the light is coming from this torch is actually, it is very broad, right? You can see the light coming from the torch, it is a very broad. But if you have the laser, now if you point the laser onto the mirror, then it is not a single ray. It is made up of multiple rays. But all of these rays, they are in a same path. They are traveling in the same path, beam of light. Yeah, this one is a beam of light. When I say ray, it means there is a laser light. There is not a torch light. Torch light, this would be a beam. This is a beam of light. And whenever I say ray of light, it means the ray which is coming from the laser. That is the meaning of ray. Very smooth, very sharp, right? That is the meaning of ray of light. So now let's understand few terms. So you have learnt incident ray. This is falling on the reflecting surface, which is our mirror. Then this is a reflected ray. So now what you do is, this is a called as point of incidence. So at which this incident ray falls on the mirror. So what you do is, draw a line which is perpendicular. So what is the meaning of normal? Normal is a line which is perpendicular to the mirror. That is the meaning of normal. So now there is a normal. The angle between normal and the incident ray called as angle of incidence. Angle between normal and reflected ray called as angle of reflection. Point of incidence, point of reflection, yes, you can call. So this here is a point of incidence, that is the point at which the ray falls onto the mirror. This is also called as point of reflection, correct? Nice. So clear all these terms. Incident ray, the rays which are going towards the mirror. Reflected rays, ray which have bounced back from the mirror. Then point of incidence, the point at which reflected ray fall on the mirror. Normal, it is a imaginary line, there is not a real line. That is why I have dotted by, there is a dotted line, right? Imaginary line, which is perpendicular here with the mirror. Then we have angle of incidence called as angle I. Angle between incident ray and the normal is called as angle of incidence. Angle of reflection, angle between reflected ray and the normal called as angle of reflection. Numericals related to this? Yes, sure, we'll solve few numericals. Farhan, Mohammed. Sure, wait, we'll at the end of this session, I mean after first 15-20 minutes, we'll solve all the numericals. So now, first law of reflection. So there are two laws. So what is the first law? This angle of incidence is always equal to, angle of reflection. They are always going to be equal to each other. That is the first law of reflection. You see here, there is an incident ray, reflected ray, there is a normal, angle of incidence, angle of reflection. Again here, incident ray, reflected ray, that dotted line is the normal, angle of incidence, angle of reflection. Always going to be equal. So even if surface is rough, let's suppose the surface is something like this. So now here I draw the incident rays. These are the incident rays. Okay, they fall on this rough surface. So what you do here, these are the points of incident. So at this point what we have to do is, we have to draw a normal. How will you draw? So this is the normal at this point. At this point the normal would be something like this. At this point normal would be something like this. You see these normals, they are not parallel to each other. And now these are your angle of incidence I. Angle of incidence have different values. So now same, you will have angles of, let's suppose this I1, I2 and I3. So similarly you will have here, these ones are, this is R1, angle of reflection 1, this is R2 and R3. These are the three angles of reflection. So even in this case, the law of reflection is true. It is valid. It cannot always, light will always obey these laws of reflection. Okay. Now the second law. Let's go to the second law of reflection. What does it say? It says that the incoming radiation, that is the incident light, the normal and the reflected light, they always lie in the plane of incidence. So they always lie in the same plane, right? Incident ray, normal, reflected ray, always lie in the same plane. So this is called as second law of reflection. So if the incident ray and the normal are within this plane of the board, then the reflected ray cannot come out or cannot go into the page, into the screen, right? It will always be within this screen, on the screen. That is the second law of reflection. So now solve this question. Okay, Mohammed, thank you so much. Don't memorize Infinity Learn. Yeah, Infinity Learn bought that channel. So now they have changed the name, correct? Yes, always. You guys are awesome. When the angle of incidence is equal to angle of reflection, and the answer is always. They are always equal. Alright, nice. Now, the image formation in a plane mirror. So you see this plane mirror, till now I am saying you can see your image in the mirror. But do you know how the image is formed? So let's consider a point object. This O is the object, right? This is a point object. You can extend this to one dimensional object like a pen. Pen is like you can consider one dimensional object, or two dimension. If you have paper, or three dimension like humans or animals, they are like three dimensional objects. So let's start with the 0 dimension, which is our point object. So these are the incident rays. So these incident rays fall on A and C. A and C, these are point of incidence. So now this AX and CY, what are these? These two are normals. They are normals, correct? So because of that, this will be our angle of incidence I1, this will be I2, right? So now these rays AB and CD, what are these? These are reflected rays. So this would be R1, this would be R2. So now can you see this BD, this AB and CD, they are going away from each other. They are going away from each other, that means they are diverging. So if they are diverging, are they going to meet? Answer is no. If they are going away from each other, how can they meet, right? So now in that case, what we do is we extrapolate them backwards. So this dotted line is the extrapolation. We go behind the mirror, and now at this point they appear to meet. They are not physically meeting here, they are virtually meeting. We are seeing each other, that is a virtual, right? We are not physically in front of each other. So similarly, this image is a virtual. It is forming behind the mirror. This PQ is the mirror, so image is behind the mirror. Clear? Hi Hari, Star. Thank you so much, beta. Alright, I won't stop, no worries. So now let's understand few of the terms here. So here this AB, so in this case this was a point object. This was a point object, right? This is a point object. Now let's go to the one dimensional object. Can you see here? This AB, this is a one dimensional object. Why R1 and R2 not parallel? You see here, the angles, this angle and this angle, they are different, and because of that they are not parallel, right? The angles are different, huh? That is the reason they are not parallel. If the angles are same, so now when we talked the incident rays, for example, if this is our mirror, this is a mirror, if the incident rays, they are parallel. And when can you have parallel incident rays? If they are coming from the object which is very far. So object is very far, something like a sun. If the object is here, sun, so there is a sunlight. Sunlight will have parallel rays. But if the object is not very far, so object is not at infinity, then these incident rays, can you see, are they parallel? The incident rays, they are not parallel. So if the incident rays are not parallel, even the reflected rays, they are not parallel. Yes, shout out. Yes, sure. Happy Shine. Then you said Chakravarti something name. Harish Sir. Alright. Nice, nice. You guys can put your original name so that I can shout out, or give maybe short form of your name. Alright. Now, you see this object? Object is AB. So what we are doing is, this point B is on this line. This line is called as principal axis. So what is principal axis? There is a principal axis. So this one is our mirror. So there is an imaginary line which is at a 90-degree angle with the mirror, and there is a center of the mirror. This point is the center of the mirror. So there is an imaginary line, parallel imaginary line called as principal axis. So now the object is kept above principal axis. Rudra, hi Rudra. Shubhashri, hi. Hari, nice. Yeah, that's good. So here, object, this point B is on the principal axis. Let's keep it as it is. This point A is above the principal axis. So these are the incident rays. Can you see? Incident ray 1 and there is the incident ray number 2. So this incident ray is along the normal. If the incident ray is along the normal, what will happen? It will fall, it will bounce back. So this would be the reflected ray. And the second incident ray falling at this point, so it will come in this direction. So there is a second reflected ray. Now again they are going away from each other. If the two rays going away from each other, what we do? We extrapolate, we go in the behind the mirror backwards. So they appear to meet at this point A prime. So this A prime, and for this B we have corresponding B prime. So this is how the image is formed. So this is a image corresponding to this object. So what are the terms? You see here, there is a height of the object, height of the image. So are these two equal? Height of the object and height of the image, are they equal? Yes. If you have the plane mirror, height of the image will always be equal to height of the object. This is for the plane mirror. Not just that, you see here U and V. What is U? U is the object distance, distance of the object from the mirror. That is the object distance. What is V? V is the distance of the image from the mirror. And for the plane mirror, we have one more property, that is U is equal to V. So these two properties are true for the plane mirror. So is the image forming on the mirror or behind the mirror? Can you tell? Is the image formed on the mirror or behind the mirror? Okay, solve this question. Behind, nice Muhammad and Rudra, great. Shubhashri, Hari, nice. So what are the properties of the image formed by a plane mirror? So when you have the image formed by the plane mirror, it is going to be at the surface of the mirror? No, that is not correct. Is it going to be behind the mirror? Yes, behind the mirror, all these are correct. Now, virtual and real. Is the image real? No, image is not real. So this option is wrong. Now, out of these, yes, it is behind the mirror. Now, it is enlarged and same size as the object. So what did we say here? Height of the image is same as height of the object. So image and object, they are same size, right? So this is correct. What is mean by enlarged? Enlarged means if the object is like this, image will be like this. Image is getting enlarged. That is the meaning of this. So that is not correct. So correct option is option number B. Awesome. Nice, all of you. Go back to the last question. You didn't understand. Which question? This one? What question was it? This was the first question only. I didn't ask many questions today. Prem, hi Prem. Good afternoon. Okay, now you see we have done the point object, then I1. Okay, just give me a minute, we'll come back to that. Then we have done a one-dimensional object. You see here, there is a three-dimensional object. So even for this three-dimensional object, you get a three-dimensional image on the mirror. So this, what are the properties again? There is a virtual image. It is forming behind the mirror. The object and the image, they have same height and it is at a same location. The location of the image, this V and this object distance from the mirror, they are equal. This is true for even the three-dimensional object. But now there is one change. You see here lateral inversion. What is the meaning of lateral? It means sideways. Sideways, what happens? If you see in the mirror, if you wave your right hand, what will happen? The right hand will become left hand in the mirror. So that is a lateral inversion. So sideways, it will be flipped. That is the meaning of lateral inversion. What is the real image? So now, have you seen a cinema screen? So nowadays we have very advanced techniques, but earlier there used to be curtains, a big curtain, and there was a flash coming from one point, and they used to show on that screen. So whenever you get an image on the screen, that is called as real image. Understood? Yes, real image is visible. So you get the image on the screen. If you put up a screen, then you can get the image on the screen. That is a real image. Virtual image, you cannot get on the screen. So whenever you get an image on the screen, that is a real image. Clear? Yes, Mohammed, correct. Now, these are the differences between real image and virtual image. Real image form when the light rays actually meet. They meet in real. So if you call your friend like a video call, that is a virtual meeting, right? They appear to meet. So the light rays, they appear to meet. That is a virtual. And if they physically meet, if they actually meet, that is a real. So they can be obtained on the screen. Virtual image cannot be obtained on the screen. Real image, they are inverted. What is inverted? If let's say in that you see the object you can show. So this is a head. There is a head and there is a tail. So even for the image, it will be like this. There is a head and tail. You see here legs and legs, head and head. So when you have these kind of image, they are called as erect image, right? These are the erect image. So head will form upright, erect or upright image. And what is the other one? Inverted. If the object is like this, there is an object, so image will form, there is an inverted image, right? So now head is pointing downwards. So that is the meaning of inverted image. So there is an erect or upright. If the object is like this, image will also be pointing upwards. So that is the meaning of erect image. So what are the examples of real image? Image form on the cinema screen, that is a real image. Virtual image formed by the plane mirror, that is a virtual image. Thank you, Hari. Alright. So now solve this. We have the word ambulance written on the ambulance as this. What is the reason? Do you know? Why the word ambulance looks something like this? Inverted image with the ray diagram. We'll learn the inverted image when we learn the spherical mirrors. On the plane mirror, you won't get the inverted image. Yes, real and inverted we'll learn when we learn in the next class. We'll learn about that. For the plane mirror, no, you don't get the inverted image. Alright, thank you, Hari, Rudra, Mohammed, Raj. Alright. So why this ambulance word is written like this? So what happens, ambulance is behind and you are on the bike or the car, then you have the mirror, right? So in that mirror, what do you see? You see the lateral inversion in your side mirror of the car or the bike. There is a lateral inversion, and because of that, this ambulance word. So lateral inversion is like there is a mirror here. So you flip it backwards. So this E will become like this, C will become like this, and so on. So this is how this ambulance word will come out. And if it is inverted, what will happen? If this word is ambulance, I will write down. Sorry. So there is an ambulance word. So if I keep a mirror here, then what will happen? Then it will be flipped in the vertical direction. So the A will look like this, M will look something like this, this B as it is, U would be, there is a U, so it would be like this. So there is a vertical inversion, got it? So there is a vertical inversion, that is a lateral meaning sideways. So where do you see this kind of inversion? If you look in the, let's suppose there is a water, right, then you get these kind of inversion. We are going to study this inverted image when we learn the spherical mirrors, alright. So the correct answer for this is, images in the mirror is a laterally inverted. Now the object is at a object of height 5 centimeter placed at a distance of 3 centimeter in front of a plane mirror. Which of the following are true? Multiple correct. So you have to choose all the correct options. Choose all the correct options. If we rotate by some angle, yes, that we are going to study in maybe after a couple of classes. If you rotate the mirror, what will happen? So I'll draw the diagram. Let's suppose this is your mirror. Object is 5 centimeter height. So let's suppose there is an object, there is a 5 centimeter height and at a distance of how much? 3 centimeter. So where will image form and what is the A and C? Okay, nice. Completely different from thumbnail. Yeah, I don't have specs now. Alright. Yes, so now this image will form behind 3 centimeter behind the mirror, and this is the object, this will be the image. So height of the image would be 5 centimeter. So which is correct? Image formed at a 3 centimeter behind the mirror, that is correct. Image formed at a 5 centimeter, not correct. Image is erect with height 5 centimeter. This is correct. Image is not inverted. This is not correct. Clear? So these are the correct options, A and C. Nice. AC current. Yes, AC current. Alright. So okay, that's it for today. So you guys like the today's class? We are going to learn a lot of new things. So for grade 10 after me, there is one more session, one more very interesting session at 4 o'clock, and Devika ma'am will teach you biology. Alright, so that's it for today. There is a Telegram channel. You can go here, you will get the PDF. So whatever we have learned today, that for not just me, all the other teachers, whatever they will teach, you will get the PDF of that in this Telegram channel. So do follow. Alright, bye bye everyone. Enjoy, take care. See you again in the next class.